We are continuing on standard F.2.4 functions. Mr. Elliott needs to drain his above-ground pool before the winter. The graph below represents the relationship between the number of gallons of water remaining in the pool and the number of hours the pool has drained. So we can obviously see that this slope is decreasing. We need to, in part A, determine the rate of change for this relationship and explain what it means. Remember, rate of change is equal to slope, is equal to that m value, is our change in y over our change in x. So let's figure this out. How is y changing? So y is going from, if I look at these 2 points, remember you can use any 2 points on a line to find its slope. Y is changing from 10,080 down to 8,640. X is changing from 0 to 2. And I can actually move this line up here. So X is changing from 0 to 2. So I could put this all over my change from 0 to 2. And when I calculate this, when I subtract 10,080 minus 806.40, I get 1,440 over negative 2, 0 minus 2. So when I divide that by negative 2, I get negative 720. So my rate of change, my slope, my rate of change, is negative 720. What this means is every hour, the pool is losing 720 gallons of water. Determine the initial value, and initial value is your starting place. So I started with 10,080 gallons. So I started with 10,080 gallons, and I'm losing 720 every hour. All right, let's go ahead and move on to the next question. A construction supply store sells steel bars for a certain price per kilogram, no matter how much steel is ordered. The company adds on the same delivery charge. The cost for an order of 100 kilograms of steel bars is $230, and the cost for an order of 150 is $320. Write an equation to show the cost of an order of steel bars, y, in terms of weight of steel bars ordered, x. Show or explain how you found your answer. So let's go ahead and show this. It's telling us that y is equal to our cost and x is equal to the weight. So let's go ahead and create a graph where my y-axis is my cost and my x-axis is the weight. So we'll use the numbers that they gave us. So at $230, the total weight I purchased was 100. At a total weight of 150, my cost was $320. So to find the equation, we need y equals mx, or y equals mx plus b. In this one, we're going to use y equals mx because we know we're going to try to find this slope. So let's try to find the slope of this line. Well, to find that slope, remember we just did this, the change in y over the change in x. So my change in y, I'll use a different color here, my change in y would be going from 320 all the way down to 230. So 320 minus 230, which gives me 90. Over my change in x, I'll change this color again. Let's do green. I'm going from 100 to 150. So I'm changing x from 150. So this would be 90 over 50, which reduces to 9 over 5. So my slope is 9/5. So y equals 9/5 x. All right, moving right along, we're almost done here. Use a graph to describe the relationship between the volume of fuel in the jet's tank over time. Suppose the graph intersected the time axis. What would this indicate with regard to the variables in this context? So we have a graph of jet fuel. And if you look down here in the bottom right-hand corner, we have now changed standards to F.2.5, which wants us to describe these relationships. So just look at this graph and let's talk about what's happening. The jet started with some amount of fuel, and over time we see this decreasing. So what does that mean? Pause the video and come up with an answer. So what I hope you came up with was that over a certain amount of time, in this case hours, the fuel in the jet is decreasing. So if this were to continue, after a certain amount of hours, I would hit the x-axis, which would mean I have no fuel left. And hopefully your plane does not get to that point. All right, so let's go ahead and interpret another graph. Alberto and Bianca run a 50-kilometer race. The illustration below shows the graph of the position of the two runners as a function of time. Complete the following sentences based on the graph of the function. Let's go ahead and start with this first sentence. Early in the race, blank is running faster. So early in our race, let's look at this race. Early on, Alberto, his rate of change is much faster than Bianca's. So early in the race, Alberto runs faster. He maintains a speed of blank kilometers per hour during the first race. So speed would be our rate of change. So we would need to calculate that. So our change in y, which would be 20, 0 to 20, over our change in x, which would be 1. So 20 over 1, he's going 20 kilometers per hour during the first hour of the race. However, after 1 hour, he gets tired, he must take a break, and he falls asleep. So at this point, Alberto's not doing anything anymore. He fell asleep for 3 hours. Meanwhile, Bianca's running speed is increasing. And if our race is 50 kilometers, so 50 kilometers, who reached this line first when we're looking at time? Well, that would be Bianca. And last but not least, which graph represents a linear function at a constant rate? Pause here, select A, B, C, or D. Your correct answer should be D. All right, guys, that is all. Hopefully you've enjoyed these two videos learning about F.2.4 and F.2.5.